Hello, everyone. My name is Mohammed Tassin. You can call me Mo. I'm an AI/ML Specialist Solutions Architect with AWS. This video was created in conjunction with Dawal Patel, who is a tech lead for Amazon Bedrock, and Claudio Mazzoni, Senior Worldwide Specialist Solutions Architect for Gen AI. Today, we're going to be going over how you can track, allocate, budget, and manage your cost and usage of yourself and your customers for applications you create with Amazon Bedrock. Amazon Bedrock is the easiest way to build and scale GenAI applications. It's an API-based service that allows you to select some of the leading foundation model families of today, like Anthropic's Claude, Meta's Llama, Amazon's Titan, or Stability AI's Stable Diffusion. You are able to fine-tune or import customized models on Amazon Bedrock. You are able to orchestrate retrieval augmented generation, or RAG. You can even orchestrate agents on this platform. And as always, you have the assurance that the prompts and responses you send and receive on Amazon Bedrock are not used or stored by Amazon and are not shared with the third-party model providers. As you can see, there's many different facets to Amazon Bedrock, but today we will solely focus on cost and usage, allocation, and spending for Amazon Bedrock applications. Now let's get into the nitty-gritties of cost tagging and management. So as an overview, first I do want to mention exactly why we are creating this video and why this aspect of Amazon Bedrock is very useful. Until now, if you were a developer that built an application on Amazon Bedrock and you had multiple users, customers, tenants, departments using said application, all of the cost and usage would go to Cost Explorer underneath Amazon Bedrock, and it would be very difficult to differentiate exactly where the usage was coming from. Of course, you could have built something custom, but then you are beholden to managing that code and adding overhead to your workflow. Now, with the built-in cost and tagging management system of Amazon Bedrock, you're able to allocate budgets and charge back your customers or users for specific usage that they incur. Like we mentioned, we use application inference profiles or IPs, and that tagging integrates seamlessly with AWS billing capabilities like Cost Explorer. You can track usage per team, department, application, tenant, whatever your workflow or application requires. Finally, you can also set budgets and define actions to prevent usage beyond a certain point. So we've been talking about inference profiles a lot. Let's break down what an inference profile actually is. An inference profile can be thought of a construct that can be called via API. This construct is related to a base model ID, and you can think of this base model ID as the underlying foundation model that will be called via Amazon Bedrock. This inference profile and base model ID are also related to an AWS region, which is the region said foundation model will be called from. Now, there are two types of inference profiles. There is a system-defined inference profile, and these inference profiles, as of today, are used for cross-region inference on Amazon Bedrock. This is a resilient type of invocation on Amazon Bedrock that will bounce between two regions depending on availability. But for today's video, the other type of inference profile are user-created inference profiles, otherwise known as application inference profiles. And this application inference profile as a construct not only contains base model IDs and a region, it also has tags associated with it that allows you to track and manage the usage and spending, which system-defined inference profiles do not have the option of attaching tags to them. Since for today's video, you were promised practicality, let's look at the scenario we will explore and see how we can flesh this out into a production environment where we can view and track the cost of these applications. We will pretend to look at any company, a company that creates many specialized chatbots for their client base. Currently, they offer two flavors of chatbots. The first one is a web search bot, and this can grab real-time data and give a natural language response to a user. The second one is a coding bot to help developers write code and ask questions. We'll take a look at how both of these applications can be managed via application inference. Now we'll take a look at how you can actually plan the number of application inference profiles you need to create. So the general formula that we recommend is your application inference profiles equals to the number of applications you have multiplied by the tenants that you have multiplied by the environments you have. Once all three of these factors are taken into account and multiplied, the number you get will be the total number of application inference profiles that you need to create. Now let's apply that formula to any company's situation. We know any company has two chatbots that they offer, the coding bot and the web search bot, hence the two applications. Next, in the scenario we will explore, for simplicity's sake, we will say that any company has two customers, customer 1 and customer 2, that are each using both applications. Lastly, we will say that we have two environments for this scenario. Any company has a production environment and a development environment where everything is ensured that it works smoothly before moving on to production. Now that we establish our variables, we can see that when we apply the formula, we will multiply the two chatbots, multiplied by the two customers, multiplied by the two environments, give us 8 inference profiles to create for this scenario. Now, let's take a look at some of the tags that will be attached to each of the inference profiles that we create. Each tag consists of a key value pair to identify it. The tags that we'll include in this scenario are the created by tag, the application ID, the tenant ID, the customer account ID, the model provider, the model name, and the environment that this IP exists in.
I'll now pass it over to Claudio to go over our in-depth solution.
Let us dive deeper into our project. We've broken down this project into two different stages, the configuration and setup stage and the inference stage. The configuration stage is driven by our configuration files. Models.json contains the pricing of the models, input and output cost. Config.json contains all the inference profile information needed for the setup, as well as the dashboard and alerts information. Our Lambda function becomes the intermediate step where we capture all the metrics at inference time and populate our dashboards. And finally, we have our API gateway setup that becomes the invocation stage between the user and the model. Finally, for demonstration purposes, we've built a Streamlit application where you will see our inference profile cost tracing work in real time. All this is set up by running the script setup.py either on the command line or directly onto the script. Begin with the setup. our inference profiles have been created, as well as our dashboards and our SNN alarms. Finally, we upload our Lambda function and a Lambda layer with the required dependencies. This might take a minute. Finally, we set up our API gateway, and we're done.
Let's take a look at our setup. To start, I want to point out that our alarms have been created, and in here, none of them have been triggered. However, this was very close. Had this been the case, the admin would have received a notification. If we navigate to our dashboard that was created, we can see our inference profiles and our dashboard as it was created, populated with some mock inferences that we have created. Finally, we have our aggregated results all shown at the bottom. You may toggle the different inference profiles at the drop-down. And this is how the dashboard looks like.
Thanks, Claudio, for that amazing overview of our solution. Now, I'd like to go over some key terms that we covered in today's video so we can keep everything in track. First, we'll review tagging. Tagging allows you to tag Amazon Bedrock resources for cost tracking and chargeback purposes. You can tag these by user, department, or even by customer. These tags integrate directly with the existing AWS tags and cost monitoring system, allowing for seamless integration. Next, we'll look at application inference profiles. You can think of these as wrappers around a Bedrock model ID and a region that can be tagged for granular cost tracking purposes. Next, we'll review CRIS, or cross-region inference. These are resilient Bedrock model endpoints that can bounce between regions to complete inference requests in a very timely manner and provide double the account quota listed in your console. Lastly, CloudWatch. This is a monitoring and observability service that provides real-time visibility into AWS resources. So for this purpose, it will allow you to visualize and log Amazon Bedrock usage and usage of specific IPs.
That brings us to the end of our video. To reiterate, application inference profiles are perfect for cost tracking and budgeting for multi-tenant environments using Amazon Bedrock. Up here on the screen, we have two QR codes. The one on the right will take you to the end-to-end solution that Claudio had demoed. And the one on the left, you'll be taken to the Amazon Bedrock webpage to check out all of the cool features we offer. With that, we hope you enjoyed this video, and we hope you build using Amazon Bedrock to showcase the art of the possible on AWS. Take care.